It is supposed to be an e-ink display, which is seen right here. This is the e-ink display that will update, well, periodically. And the idea is that it's a poster that just kind of hangs out, consumes no power, and only consumes power on updating. That's why we chose e-ink. This device is powered off of lithium-ion batteries. These are 3.7 volts each, about 4 volts each, and you'll see later on we have the regulator in there, and they do fit. It does fit into the case. This is our case. It does fit into the bottom of the case. Close to the camera, but there we go. So this is the lid. Just slides in like that. Okay, so what it does is you can save, you can load, you can change the evolution method, which we'll show in a little bit. So what we want to do first, we're going to load up a picture. Here's just some sample pictures. This e-ink screen updating, you can see its refresh rate is quite low, which is another reason why we needed a monitor to show. This in, we'll just kick out of this and we'll show you what it does. Takes a little bit. There's just a little bit of load time depending on the picture size. It's just processing the data until it takes time. Okay, so there's the picture. Right now we have all evolution methods that we have active, so you'll see what it does in just a second. And this is this is kind of the picture evolving. But you can see this is the RPi, this is the ribbon, again, it didn't really fit in. Now we're going to crack open the case, you're going to see what's inside of it. If I can get it off. This is what's inside of the case. This is our e-ink screen, and this is kind of why we chose it, because it already has this nice little breakout board. It's for development, so we wanted to mess with it as soon as possible, probably because it took so long to get here. It was a long order. You can see the battery underneath, the wires, they're kind of just tucked in there. It's a very small case, so they're just in there. And of course, our PCB. The PCB has the 2 buttons. It does have a regulator. I'll turn it over a second. 2 capacitors that go to the regulator, and of course, the regulator is down here. It has a heatsink on it because this does get quite warm, so we wanted to make sure that it didn't overheat or anything. We needed to heatsink it, basically. We just decided it was better. Okay, so now what we're going to do, we're going to show you the nice part about e-ink. This is the main draw of e-ink, is that when you take it out, there's no power connect to it, but you can see that the image is preserved. This is titanium oxide e-ink screen, if I'm not mistaken, and that's just going, and the particles, because they can be, they float to the surface or sink depending on the voltage, but they stay there even if there's no potential difference, there's no current, anything applied to it. So it only consumes power if it's changing. Otherwise, it just keeps the image. That was the idea behind a poster, but we couldn't get one in color. Couldn't get one that was, well, we could have gotten one that was a little bit bigger, but it would have taken us too long to get this breakout going. So what we really wanted was one that's bigger and color, but we couldn't get either. So that's why we're stuck using this smaller one. That's the entire project, and you see parts just slide back in. The lid just goes on top, and that's our project.